Back when I was in college, one of the questions I had, it was in a geology class, I believe. So the question dealt with the center of the earth, and they said, all right, it's made out of, X percentage of nickel, X percentage of iron, so on and so forth. I was like, hey, man. So my understanding is that we understand the composition of the center of the earth based on the radio waves that we send down and a few other tests, but mostly the radio waves. Like they bounce back at a certain frequency and it takes a certain amount of time to get there and back. So
I'm
as a
pretty sure it's
professor, I'm like,
seismic
hey, man.
waves, not radio waves, but that makes sense.
Yeah,
I
yeah, yeah,
think
sound wave.
I don't think that teaches us about the composition. I think that teaches us about which parts of it are solid versus liquid and what their densities are. From what I understand, you get the composition of the core. That's derived from a few things. One, Earth has a magnetic field, so there has to be some sort of magnetic or some sort of material capable of generating a magnetic field within our planet. And iron, nickel, and cobalt can do that, but iron's far more common. Earth is was made from collisions of asteroids, and we know that asteroids there are quite a lot of iron is just a common thing you find in asteroids. Then also we know the density of Earth, and we know the density of Earth at the surface, and it's density of Earth at the surface is like 3.5 grams per centimeter cubed, but Earth overall is 5.53 roughly. So there needs to be something more dense than the rocks at the surface inside the core of our planet, and iron gets you there. And it also works very well with what else we know about like meteorite composition and the fact that we have a magnetic field, and maybe some other things too. But anyways,
Sure, sure, absolutely. And that's not to really discount. And it's been a while since I've been in college. It's been like over, 2 decades. But uh, basically, what I was getting at with him was the professor was like, hey, man, given all these things could be true, like we've never actually observed, seen, sampled, or experimented on anything in the actual core of the earth. We're using these other things that, like, hey, this mimics this, right? So this mimics iron. So the density mimics iron, or we know that iron can help produce the magnetic fields. The question I had was, if there are other unknown variables that could produce similar results that we are currently unaware of, could it also not be made of such? He said, all right, so this is like a scientific mind, right? In query based on variables that could be, I guess, the further out we go in the universe, the further out in time we go, or even the smaller we go, the more unexpected and unknown variables we encounter. So I guess the idea of the Big Bang being a fact, being as it was so long ago and it reaches to such a large extent, how many unknown variables are we not accounting for that could actually say, hey, okay, it wasn't the Big Bang, it just currently looks like a Big Bang based on what we know, based on what we can observe in this current time?
um, I mean, I don't know what you mean by that. But funny enough, the farther away we look, the farther back in time we see. So
Right.
we're not. It's not the same as a crime scene where the longer you wait, the less evidence you have. Actually, the farther we look, the more evidence we get, and not just because you're doing more looking. I mean, space is very spacey all throughout it. So you'd think like, well, I mean, you're not seeing anything new. Just another galaxy. Oh, another galaxy. It's like when you drive down the highway. Yep, another telephone pole. That's what they had 100 miles ago too. But no, you actually see farther back in time when you the farther out we look, and by doing that, there are quite a lot of observations that are consistent with a. We've built our Big Bang model around those. So I mean,
So,
like,
so I would
well,
agree
anyways,
that you can see further back, but I guess what I'm saying is the further back in time you go, the less you understand about it, right?
is that the case?
So for
we have,
example,
we have
if
a
you were to
few a
pinpoint
few Planck
yesterday,
seconds at the beginning. That's very difficult for us, but the rest is not. I mean, we know it to a very very high degree.
uh, all right, so let me throw out this like my framework of my mind here. So if you look at yesterday or tomorrow, you have a high probability of guessing what accurately happened the closer to yourself you are.
Yeah.
And then if you go back 2 days or go forward in 2 days, you still have a pretty high probability, but slightly less.
Yeah, but what you're talking about is interpreting evidence
Right?
now in
Based
time
on the amount of
of
evidence
things that
available.
happened a long time ago. But when we look deep into space, we're we're looking at the early universe. You're actually looking back in time, seeing what was happening. It's very
You
different from getting to a crime scene that's many days old and trying to figure out what happened. It's more
you
like being able to look at somebody's like a security camera at the time of the event.
right,
Maybe a
but
blurry camera, but
yes, blurry. Exactly,
extremely
exactly.
well. Yeah, but that's vastly better than not being able to look back in time at all.
No, 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 no. I'm saying the further away in time you go, the less data you have about it. So while we can maybe pinpoint some small evidence about the past by looking directly at it, the further out we look, the size of the universe is increasing the further out you look, right? So like you're pinpointing on one small spot, but the further out you look, the larger that ratio of things to look at is. So the higher the increase of unknown variables becomes.
No, I have no idea what you're trying to argue.
All right, so I guess what I'm saying is like the closer to the observer and the more things that can be experimented upon, the more things can be known as objectively true. So inside your room right now, you would have an extremely high degree of accuracy of telling me what exactly is in your room.
Yeah.
But the smaller you go down to subatomic particles, like the more data you're missing because you're pinpointing on a smaller and smaller point of focus, right?
What? Why would zooming in at the atomic level mean that I know less about what I'm looking at?
So if I ask you how many doors are in your room, you could tell me how many doors with a high degree of accuracy. One door, two doors, right?
Yeah, just one.
All right. If I were to ask you precisely exactly how many quarks are in your room, you could get an estimate, but you're not going to get precisely exact because you cannot count each individual one because your point of focus is too narrow. Does that make sense?
Yeah, that makes sense.
All right. It's the same thing for going out further away from you. So the smaller you go or the larger you go, the further in time forward or the further in time backwards you go, you're getting to where your focus is still narrow on a single point, but the further back you go, the more space there is around that point you're focused on. So the less you're actually observing. You're making larger and larger estimates based on your small amount of data.
Um, in a way, I suppose.
So I guess my question isn't like I would agree the Big Bang is a great working model and the best with the available evidence we have currently today. But the further in time you go, and also the larger or smaller in size you go, the more unknown variables are out there that we can't account for because our focus is so narrow. And therefore, I don't think we can say it's
I mean,
objectively a fact.
oh, well, you completely lost me when you said that. Um, I mean, so what do I want to say? Like, let's say I use this analogy in one of the books I wrote, but it's like if we were to look at satellite imagery of the Earth, and we were to look at the Amazon rainforest, what color would you say it is?
I'm just presuming here. I speculate green
Green,
from the
right?
top.
But you do know that there are blue butterflies in the Amazon rainforest, right?
Absolutely.
So isn't the Amazon rainforest also at least a little bit blue?
I would assume so.
Okay. Now, the satellite doesn't have the resolution to be able to pick up those blue butterflies. So, does that mean that because we're looking at it from that level of analysis, we don't know as much about the color of the rainforest as we would if we were like right there? I guess. But does that actually belie anything we know about what we're trying to study? Do those tiny little butterflies really actually affect, like, are they anything other than negligible? I would say no, absolutely not. Even though it would
I would.
it would increase our precision. I would still say they're insignificant. I mean, they're unimportant, right? Now,
Okay,
when we're
dealing with the color from a large distance, yes.
yeah,
But if you're talking about understanding, let's say, the types of organisms in the rainforest, like there are certain organisms we haven't even yet discovered, I would assume, right?
probably,
Okay. So they're unknown variables, right?
yeah,
So the larger, like we could say, okay, in a 10 square meter area we've discovered almost, if not every single organism that exists.
sure.
But the further out from that goes, the more the more things we don't know.
Yeah, sure. But does the I mean, I feel like we're just picking nits here, like with regard to things that aren't really that important. So like when we go to the Big Bang, if we want to understand like the universe and its general composition and the way it expands, the rate at which it's doing that, so on and so forth, we only want to look at it from that macro level because getting finer and finer detail, I just simply don't think you're going to find things at that finer level of detail that are going to tell you anything more about what you're trying to study. Just like, yeah, I mean, sure, there's probably a billion blue butterflies in the Amazon rainforest, but it's still green, you know? Um, so I mean
That that's a valid point. But let's presume, and I can't really use the analogy; it seems to break down. So my apologies. Let's assume there was some variable in the past that we're not accounting for, given it sped up and then slowed down and then sped up again. The speed of acceleration of mass outward. We would not necessarily be able to designate that at this particular point in time, right?
Yeah, probably not, but I mean that wouldn't disprove what we already know.
But it would throw a huge kink in our models if we were able to somehow discover that. But we wouldn't know it because of how far back in time it was if we can't exactly observe that from a macro level, which whenever we observe the past through telescopes, we're observing a very narrow focused point. We're not observing
Yeah,
the
no,
largest expanses.
I actually don't think that that would be a significant problem with regard to what we already know. Like with evolution, after we discovered genetics, that had the potential. Like genetics could have falsified evolution. It absolutely could have, because if we found out that no organisms on Earth are related, or if organisms on Earth each independently use a completely different hereditary molecule, that would certainly mean that they aren't related either. Or even if they do, but the assumptions we guessed about, well, pretty sure humans are primates, right? And we're mammals to a lesser degree. We are mammal, or like in a more general sense, I should say, we are mammals, and in an even more general sense, we are vertebrates. So we should see nested hierarchies of relationship with organisms going in that order, and that is exactly what we found. Now you can argue that genetics doesn't prove with 100% certainty, because scientifically we don't really say that that is a thing that we ever really accomplish. It didn't prove with 100% certainty evolution, but we know exactly what the evidence that would have disproved it was. I just told you what it was, and that isn't what we
Some
found. In
of
fact,
we
we
know
found we
some of
found
the
out
potential.
exactly what was consistent with it. And the main reason I bring this up is that added information didn't actually change anything about what we assumed with evolution in the first place, the basic premises of it.
Sure. Sure. So I guess just from a scientific mind, or standpoint, I guess what I'm saying is, would you be willing to admit that there is a potential or some possibility for some variable we have not encountered yet on our limited framework that could mirror or mimic, basically all the evidence that we're observing and attributing to one thing? Could it be possible that there is some other thing that caused that we just haven't been able to understand at this point in time?
I think that's always the case, and I think that is like literally the spirit of what science is. That's also
Right.
kind of history. Like a good historian assumes that what we know about the past isn't true. Now that might actually, and it's kind of the same for science. Now, that might seem kind of weird because, I mean, really, that's not really how it seems that we do science or history.
Hmm.
But if we didn't assume that, why would we do any history? What would be the
Right.
point? You know, you're assuming it's not. You should be a skeptic. This is something that I hear, you know, people that like actual academics that study the Bible say. They're like, well, no, you should assume that none of it's true, and then you go and
Hmm.
look. And it's not because you're trying to disprove everything that we know. It's because you're trying to figure out what actually can be demonstrated to be known, basically.
Sure. And so, and I guess that's why when I started, I asked you to define, fact, because I guess if there is room for skepticism, if it's unobservable, you can't experiment on it, you can't repeat it. I just want to make sure there's room left for the idea of, hey, like there could be something else out there that explains this that we just don't know yet.
Yeah, science has questions that have not yet been answered, but it doesn't have answers that can't be questioned. There are belief
Mhm,
systems that
mhm.
operate that way, but science doesn't work that way. And fun fact, I'm writing a book called Facts That Aren't True, which sounds like you can't call a book that's paradoxical or whatever. But I just want to read the second paragraph of the book because it makes the point, and I think it also goes to what you're talking about here. It's no secret that things historically regarded as facts, often for logical reasons, turned out not to be true. There have also been claims that nobody ever bothered to check for their validity, but they became so widespread that they became accepted as facts. These are also called factoids. These two cases are the facts I'm talking about, facts that aren't true. It's fair to argue that these were never facts to begin with, but if we admit that we could be wrong about anything, now all of a sudden, calling anything a fact begins to sound intellectually dishonest. Despite the inevitability that some of what we claim to know today will be proven wrong in the future, I'm not willing to stop calling those claims facts. So there we go.
Awesome. I'm gonna let you go. I appreciate you, and when I do, I just want to give you one factoid since you mentioned that, and I just learned this the other day. If you don't mind.
No, I don't mind at all.
Everybody knew for a fact back in well, I guess John Milton's era and forward, uh, elephants did not have knees. They did not have joints. So,
I've
just
heard
a fun fact for you.
I heard James May say that once, and he's really smart, so I have no idea why. Or no, he didn't say that. He said something else. He said somebody asked him for a cool fact, and he said the elephant is the only animal whose knees all bend forward. Because you know when you look at like a typical quadruped animal, it looks like they have a backward facing knee, right? Like think of a
Mhm.
giraffe or a deer or a kangaroo or a cat or a dog or whatever. And I was like, how did you screw that up so bad? Because that's the heel of the animal. They just have extremely long tarsal bones. So yeah, the elephant thing that's kind of funny. It doesn't look like they do, but they do.
Right, absolutely. I'm gonna give you a follow. I appreciate you, sir.
You're welcome.